In this video, we are going to learn about pH and how pH scale is defined. Antekakanda, we are also going to learn about importance of pH in our daily life. This video chivari varaku chundi so that you understand the concept well. Okay? Let us now learn about pH scale. We know that indicators are helping us to understand whether given substance is an acid or a base, right? Let's say litmus papers are indicators. I have red litmus paper and I am dipping that into one solution. Okay, it retains its color. And I have blue litmus paper, I have dipped that into the same solution, it has become red. What is this? That substance is acid, right? And if I have red litmus paper, if I dip that into another solution, if it becomes blue, then that solution is base, right? How do we know now? The question is, how do we know whether given substance is weak acid or strong acid, dilute acid or concentrated acid? How do I know? Indicator is going to tell you whether it is acid or base, right? So indicator is not going to help whether the given substance is a weak acid or strong acid. Strong acid only, but diluted or concentrated, or weak acid only, whether it is diluted or concentrated. How am I going to know? Right? This is the question. To answer this question, you see here, pH scale, which we are going to learn now, is going to help us with this. With the help of pH scale, I'll be able to say whether given substance is weak acid, strong acid, weak base, strong base, or diluted or concentrated. All that, right? pH is a measure of acidity or alkalinity. In other words, measure of basicity. Remember this. Indicator is going to tell me acid or base. But pH is going to tell me what is its acidity. Is it a strong acid? Is it a weak acid? Is it highly concentrated acid? Or is it dilute acid? It is going to talk about even basicity. Is it a strong base? Is it a weak base? Or diluted? All that. So pH scale is going to range from 0 to 14. So 7 here is neutral. pH scale starts from 0 to 14. It goes up to 14, right? 14 indicates strong alkali or strong base, and 0 indicates strong acid. Okay, and 7 is the neutral. pH of neutral solution is 7. Less than 7, acids, but more the difference or the more the distance you are on this scale, more acidic. Lower pH indicates stronger acid. From 7, if you are going on this side, more you are traveling this side, higher the pH and stronger the base. You look at this. From 11 to 14, they are saying this is strong base, right? This is weak base, 8 to 10. 7 is neutral, and 3 to 6 is weak, and 0 to 2 is strong acid. That's what the scale is telling you, right? Note this point, dilution lead to change in pH of acids. For example, I have H2SO4. Okay, it is a strong acid and its pH goes around 0. But if I start diluting it, it is going to change the pH of that acid. So from strong acid, you can see this highly acidic, weakly acidic. Strong acid, weak acid is 1. And other thing is near 0, you have highly acidic solutions. And near to 6, 5, these are weakly acidic. You understood? Dilute acid or concentrated acid. For example, if I take H2SO4 concentrated, pH is going to be 0. And if I take dilute H2SO4, its pH can be something like 3, 4, 5, depends on degree of dilution. Same is going to happen with alkali also. If I take strong base, let's say its pH is 14 and I have diluted, let's say a lot of water I have added to it, then its pH is going to come down to 8 or 9, something like that. You understood? Dilution leads to change in pH of the acids. In the essence, what pH is going to tell you? We said that it is a measure of acidity or basicity. Okay? From that figure, you have seen that whether it is a weak acid or strong acid, it is going to tell you. Right? At the same time, it is going to tell you whether it is highly acidic or weakly acidic, highly basic or weakly basic. Please note this. This is going to be the measure because pH is indicating the concentration of hydrogen ions in the solution. We said in the case of strong acids, all the acid molecules, for example HCl, is dissociated into H plus and Cl minus ions. Means lot of concentration, high concentration of H plus ions are available. Right? Now when I dilute, this concentration is going to come down. Right? So pH is indicating the concentration of hydrogen plus ions. Okay? Even in bases also you will have certain concentration of hydrogen plus ions. Okay? Because they are mixed with water, you have H plus ion concentration, but that will be much smaller compared to the hydrogen ion concentration you have for strong acids. Okay? So dilution is going to shift the pH. Please note this. Dilution is going to change the pH. And ఇంతకు ముందు మనం చెప్పుకున్న వీక్ యాసిడ్స్ ఏవైతే ఉన్నాయో అందులో H plus ion కాన్సన్ట్రేషన్ తక్కువ ఉంటుంది. ఎందుకంటే దే ఆర్ ఓన్లీ పార్షియల్లీ డిసోసియేటెడ్. ఆల్రెడీ కాన్సన్ట్రేషన్ తక్కువ ఉంది. And if I dilute it, the concentration is going to further reduce. You understood? pH of solution is measured by using pH papers, universal pH indicator solutions and pH meter. మనం ఏదైనా వాడచ్చు. ఫర్ ఎగ్జాంపుల్ pH papers తీసుకోండి. These are bunch of papers, chemical coated. Different dyes are used to coat these papers. Okay? When you dip these papers into any of the solution, for example, you take dilute acid and dip it. Dilute acid, its concentration is, let's say, its pH is 5. You dip it and see the color change. Finally, it comes to this color. When you dip this paper, fresh paper, into H2SO4, okay, let's say, or HCl, its pH is 1. Then this paper color is going to turn to this red. If you dip the pH paper in NaOH solution which is of pH 14, then this yellow color paper is going to turn to this kind of violet. Understood? So this is use and throw kind of paper. And you have universal pH indicators. For example, you have you can add few drops of this pH indicator to a given solution. For example, I can start with HCl and add few drops of this. Then manaki scale color code ila ichuntaru. Then you should match it. For example, I have unknown solution. Dintlo maybe 1 or 2 drops of this solution, this liquid I add. And slowly దీని కలర్ చేంజ్ అవుతుంది. ఆ కలర్ ఎక్కడ మ్యాచ్ అవుతుందో చూస్తాం. ఫర్ ఎగ్జాంపుల్ ఎండ్ ఆఫ్ మిక్సింగ్, వెల్ లెట్స్ సే ఇట్ కమ్స్ టు దిస్ కలర్. ఓకే, ద సొల్యూషన్ కమ్స్ టు దిస్ కలర్. Then I can say that pH of this particular solution is 9. If I take another solution and add few drops of this liquid, let's say the color changes to this kind of red color, red to orange, then I can say that the pH is 1. This is how we are going to make use of universal pH indicators to identify whether the pH is high or low, 0 to 14, any number. Right? For example, I know that there is one concentrated HCl and there is another dilute HCl. Okay? How do I differentiate? మన దగ్గర 2 బేకర్లో ఒక దాంట్లో కాన్సన్ట్రేటెడ్ HCl ఉంది, ఇంకో దాంట్లో డైల్యూట్ HCl ఉంది. We know that we should not handle carelessly the concentrated HCl, right? చాలా కేర్ఫుల్గా హ్యాండిల్ చేయాలి. And you are otherwise you don't want your students to touch it. Then how do I know this? Both the solutions are looking similar, let's say. How do I know this? Either I can use this pH paper or I can use this indicator to figure out what is concentrated HCl. Now concentrated HCl pH may be coming around 1. Dilute HCl, depending upon dilution, let's say it is coming around 5. You understood? That is the purpose of it. And in the other case, I have, let's say, poured HCl and formic acid into 2 different beakers, but forgot to tick the tag. Now what I have to do? I know that formic acid is weak acid and hydrochloric acid is strong acid. Now with the help of pH meter or pH indicators, I can say which is HCl and which is HCOH, right? And that's the purpose you need these. Okay, and we have even pH meters. You simply dip it and this meter is going to show you what is the pH. For example, you have a solution here, it says that its pH is 6.68. That is the beauty of these meters. These meters are going to give you much finely resolved scale. ఇక్కడ మనకు చూస్తే కనుక 0 to 14, 1, 2, 3, 4 ఇలా ఉంది. But ఇక్కడ you have even higher resolution, right? So that's the help you get when you use these meters. Okay? Now, knowing pH of various substances is important. మనకు తెలియాలి. pH meter గురించి, pH measurement గురించి నేర్చుకున్నాం. But why one should be bothered? అంటే ఇది చాలా ఇంపార్టెంట్ తెలియడం. pH గురించి తెలియడం అనేది చాలా ఇంపార్టెంట్. ఎందుకంటే it can help us understand how they interact with other substances or how they react with other substances and living organisms. And it is also important for our safety. For example, మీకు లేబుల్ చేయకుండా HCl సొల్యూషన్ ఒక బాటిల్లో పెట్టారనుకుందాం. Okay? It is next to your water bottle. Both the bottles are looking same. Right? There is a risk. అనుకోకుండా మీరు HCl, dilute HCl సొల్యూషన్ తాగేశారనుకుందాం. It can affect your health, right? So, ఇప్పుడు you know that there is HCl solution bottle. Then with the help of pH meter, you can say which is HCl and which is water. Right? So this is important. And second thing is, what kind of reactions you can expect. Rigorous reaction or slow reaction. Whether the given substance is going to react with base or not. How do I know? Unless I know pH. Right? And living organisms is also important. For example, let's say you have acid water. Me laboratory you have done some experiment and you have got acidic water. You should not pour this anywhere. It has to be treated first. For example, you have a pond nearby your school. You take this acid water and pour it. It can potentially kill few fishes in the pond, right? For that reason, it is important to know what is the pH of various substances, and this is also important for our safety. For example, battery acid, sulfuric acid is used in batteries and its pH is 0. Lemon juice is going to have 2.2, of course around 3. Vinegar is also going to be having around 3. And soft drinks, for example, Coca-Cola and all you drink, right? They are also acidic. Their pH is around 3. These are all some sort of strong acids, right? I don't call them strong acids. They are more acidic, highly acidic. I should call. I don't know whether the soft drink is a strong acid or not, right? Let's not call them strong acids. Let's call them highly acidic. And now you have your saliva, the rainwater, milk. These are weakly acidic. Please note this. Highly acidic, weakly acidic. Okay? And then pure water. For example, you evaporate water. You heat the water such that water vapor comes and collect the water. Collect that vapor and let it condense. This is called distillation, right? That pure water has pH 7. You see, that is neutral solution. And you have blood 7.4. Seawater is more alkaline compared to your blood. And baking soda is 8.3. Magnesium hydroxide, which is used in antacids, it is 10.5. Calcium hydroxide, which is used to treat soil pH and all, that is 12.4. And sodium hydroxide, that is 14. This is strong base and this is strong acid. Okay, you call this as highly acidic. This is weakly acidic, weakly basic, highly basic. Let's call them like this. Don't call them weak acid, strong bases, weak bases, because their definition is different. It talks about dissociation, degree of dissociation of the molecules into ions. But this is fair enough. Okay? Let us now discuss about importance of pH in everyday life. Plants and animals are pH sensitive. Please note this. pH is going to affect life of plants and life of animals, including us. In living organisms, maintaining right pH is essential for proper physiological functions. Please note this. Human blood has narrow pH range 7.3 to 7.5. If something goes wrong and pH changes to, let's say, 6.8 or 7.8, then these deviations are going to lead to health problems. The deviations from this range, pH of blood should be within this range. If it is changing for some reason, then it leads to health problems. Please note that. And enzymes are vital for biological process. For example, you eat something, it has to get digested, right? Some enzymes are playing a vital role, right? They also have specific pH ranges to function optimally. For example, saliva has got pH of 6.5 to 7.5. And you have, let's say, small intestine 4 to 7, the pH range. Large intestine 4 to 7. And in the stomach, you have 1.5 to 4. And upper stomach, you have 4 to 6.5. If you do something which affects any of these pHs, then it is going to affect overall digestion process. Please note this. And once you have some problems with your digestion, it is going to affect your health, right? So maintaining right pH is essential for proper physiological functions. For example, if pH of mouth goes below 5.5, it is going to cause tooth decay. Tooth decay ante you have calcium phosphate enamel covered over your tooth. Okay, that is going to get corroded. For example, మనల్ని సాఫ్ట్ డ్రింక్స్ ఎక్కువగా తీసుకోవద్దు అంటారు. కోకోకోలా ఇలాంటివి ఎక్కువగా కన్జ్యూమ్ చేయొద్దు అంటారు, రైట్? ఎందుకు? We have seen that their pH is 3, right? If you are taking lot of amounts of Coca-Cola kind of soft drinks, then temporarily at least your saliva pH and pH in the mouth is going to decrease, right? 6.5 to 7.5 undalsindalla, since it is mixed with a solution of 3 pH, it is going to change, right? So let's say it comes to 4.5. 4.5 is acidic and it can interact with calcium phosphate. Calcium phosphate తో రియాక్ట్ అవ్వచ్చు. రియాక్ట్ అవుతుందంటే ఏంటి? The enamel is getting corroded. After some time you will have tooth decay, right? Meaning your tooth will be sensitive. కూల్ డ్రింక్స్ తీసుకున్నా లేకపోతే ఐస్ క్రీమ్ లాంటివి తిన్నా యూ గెట్ లాట్ ఆఫ్ పెయిన్. ఎందుకు జరుగుతుంది అది అంటే the enamel is corroded or eroded. So the protection layer is gone, right? That's why maintaining pH of mouth is also important. In the case of indigestion, digestion problem వచ్చింది మనకి. In that case what happens is excessive HCl is released in the stomach to address that indigestion problem. But unfortunately that leads to acidity. మనకు తెలుసు when you have acidity problem you have burning sensation, right? And sometimes it can also cause ulcers in the stomach. To address that, doctor is going to prescribe antacids, right? And what antacids do? Antacids are going to neutralize the excess acid present in the digestive system or in the stomach, right? This is what is going to happen. So it is very important we have to maintain the right pH for every function to happen properly. If any imbalance happens, that is going to lead to some health related problems. Not only this, it is going to affect even environment, it is going to affect plants and many things. When pH of rainwater is less than 5.6, we call that as acid rain. కొన్నిసార్లు యాసిడ్ రెయిన్స్ పడుతున్నాయని you must have read on newspapers, right? When this happens, the rainwater is going to affect the pH of the soil, right? Acid rains are going to affect pH of soil to impact plant growth. Please note this. Plants require certain pH to absorb nutrients and their healthy growth. You look at this. Bioavailability of plant nutrients to soil pH. This is the relation. When soil pH is more of acidic from 4 to 6, you see for plants you are not getting NPK. These are not readily available for the plants to consume. Whereas when the pH is in the range of 6 to 8, you see a lot of elements are available. You have N, you have P, you have K available, and then you have zinc. These are minerals available, zinc, manganese, magnesium. That's why the plant growth is better. And even in the extreme basic conditions or alkaline conditions, plant growth is again suppressed because vital elements are missing. You know, NPK is very much important for the plant to grow, right? When you look at this figure, it says that we need to have pH in the range of 6 to 8. pH of the soil in the range of 6 to 8 such that the plants can grow fast or plants can grow normally. Otherwise, their growth is going to get impacted, right? And if acid rains are happening very frequently, then certainly the soil pH is going to come down, right? And one fine day, we may end up with soils of this quality. It is terrible for plants to grow, and then we'll have all sort of problems. We may not have food, right? Acid rains can also affect water bodies to impact aquatic life. We have said, you know, aquatic life means fishes, anything that lives in water. Their lifestyle or their life also can get affected because of acid rains. Acid rains okate kaadu problem. For example, you have a lot of factories. They generate a lot of wastewater, right? We have seen that pure water is of pH 7 and seawater is about 8. But then the water coming out of certain plants, factories, maybe of pH of 2, pH of 3, or pH of 10, pH of 11. When you mix this into water bodies, or if you release that water into water bodies, it is going to contaminate the water, right? The water bodies pH also can get changed, and that can impact aquatic life, right? For that reason, one has to adjust pH of wastewater before it is discharged into water body. Factories lo generate అయిన waste water అంతా సింపుల్ గా డంప్ చేసేయకూడదు. It has to be treated. To take care of this, we have a pollution control board and few other organizations. Understood what is the importance of pH in everyday life?